Welcome back, grade 8, to another math video. This math video, our lesson part is going to be very short, but the examples might take a little bit more of our time. Again, the examples are a little bit more optional, but if you choose to listen to them, then you're welcome to. So for this video, the main concept that we're going to be going over and that we're going to be using in solving a question is the idea that the angle sum of a triangle is 180 degrees. So the angle sum, what that means is that when we add all the angles together of a triangle, it is 180 degrees, always, no matter what. And so we use this information in order to be able to solve any type of question. So using that information, if we know two of the angles, we can solve the third. And that's about it for this lesson. It seems very simplistic, but we're going to use that information about the angle sum of a triangle as well as some of our previous information on parallel lines in order to solve some questions. So if you'd like, you can try some of the questions on your own. Otherwise, you can stick around and we're going to walk through some of the examples. Example 4 and 5 that's going to parallel with your try it 4 and 5 for your math questions. Example 4, it gives us a triangle to start. And it gives us a particular type of triangle, as well as some parallel lines here. So we have this line, this is a parallel line. And then we're also told some information here, and that's with these two lines here. What those two lines symbolize is this is a special type of triangle called an isosceles triangle. And what that means, and we've talked about these lines before, is that these lines are exactly the same length. What that also means, let's just write in some of the other things here. We know that this is 63 degrees. We're asked to figure out this x, this y, and this z. What that means is if it's an isosceles triangle, that these two angles here are identical. They must be exactly the same. Where these two same lines meet, that can be different, but these two angles are going to be exactly the same. Okay, well, let's see if we can use some of that information in order to solve for the rest of this particular question. Well, it might seem a little bit tricky. Let's extend out our parallel lines in order to make it look a little bit bigger here. And we actually get a bit of a Z pattern here. So with our Z pattern, we know that our interior angles must be the same. So if this is 63 degrees, then angle Z must be 63 degrees as well. And because this is an isosceles triangle, if this is 63 degrees, then angle Y must also be 63 degrees. So that just leaves us with angle X. Well, a triangle must equal 180 degrees. So these two added together is 126 degrees. So plus angle X is going to give us the entire 180 for the triangle. I just need to figure out what's left. If I move things around a little bit, I just take 180 minus 126, and that would give me an X angle or an X value of 54 degrees. So that's how we figure out Z, Y, and X for this particular example question. Let's go over another one similar to that. Let's go over example 5 now. In this case, we're given a different type of triangle. Let's draw it the best we can here. And actually, it's two triangles on top of each other. And we know that we have double lines here, 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 and here. So actually, what this tells us is that this triangle here is another one of those isosceles triangles that we dealt with before. We have angle Y that we have to solve as well as X here. We actually have no other numbers on this triangle, but we're just asked to solve X and Y. This triangle, though, is a special type of triangle called an equilateral triangle. All sides are equal, they're all the same length, but what that also means is that all the angles are the same. They're the same as each other. Everything has to equal 180 within this triangle, so what angle can we use where if we add all three together, we get 180? maybe you've taken some time to think about that. Maybe you know that right off the bat, but it's 60 degrees. So this is 60, this is 60, and this must be 60. Okay. Now let's see if we can figure out x. Well, remember, this is a straight line. So from here to here must equal 180 degrees in a straight line. If this is 60, then 180 minus 60 degrees means that my x must equal 120 degrees. Okay, so we figured out x, 120 degrees. Now we have to figure out y. Well, y is a part of an isosceles triangle. So although this is x, we know that y and this have to be the same, and all three together have to equal 180. So if x is 120, from the 180, that means we have 60 degrees left. And we have to split that 60 degrees evenly between these two angles, which means that 30 degrees goes here and 30 degrees goes here. So because of that, our y value must be 30 degrees in solving this particular question. We're able to use our information about a triangle equaling 180 degrees, as well as information about both equilateral and isosceles triangles in order to solve, as well as complementary angles, in order to solve for what was missing. Hopefully that helps if you're a little bit stuck in going through these particular example questions. And please remember that try it 4 pairs perfectly with example 4, and try it 5 pairs perfectly with example 5.